We're going to start off Unit 4 by talking about L'Hopital's rule. Now, this is a new method for computing limits algebraically. So I know some of you weren't a huge fan of Unit 1. There was a lot of stuff going on there, but believe me when I tell you that this is actually a fan favorite for computing limits using L'Hopital's rule. So here I just want to recall that within the limit, 0 over 0 and plus or minus infinity over plus or minus infinity are indeterminate forms, meaning we have no idea what the limit of the function is or if it even exists until we use some sort of algebra techniques. Okay, so if we plug in the value that we are approaching for our limit into the function and we get either of these forms, 0 over 0 or some form of infinity over some form of infinity, then we cannot say what the limit is yet. We have to do some sort of limit technique there. All right, so this is our new limit technique, L'Hopital's rule. And so today we're just going to talk about if we get the indeterminate form 0 over 0, how to apply L'Hopital's rule. So here, officially the rule says that if f and g are differentiable functions, and the limit as x approaches a of f of x is equal to the limit as x approaches a of g of x, which is equal to 0, then the limit as x approaches a of f of x over g of x is just equal to the limit as x approaches a of the derivative of f divided by the derivative of g. And then it just says provided the limit on the right-hand side exists. So basically what L'Hopital allows us to do is that if we plug in our value into the function and we get our indeterminate form 0 over 0, what L'Hopital's rule says we can do is we can say that that's equal to the limit of the derivative of the top divided by the derivative of the bottom. Okay, and so you want to make sure that you recognize that L'Hopital's rule is not using quotient rule there to tell me that the derivative of f divided by g is the derivative of the top divided by the derivative of the bottom, because that is incorrect. That's just the special part that comes with L'Hopital's rule that you can actually compute the limit using that technique. Okay, so let's do an example. All right, so it says compute the limit as x approaches 0 of e to the 2x minus 1 over x. So remember, the first thing we want to do is plug in 0 into the function. So wherever I see x, I'm plugging in 0. So throwing this back to Unit 1. So over here, I'm going to do some side work. So I'm going to say that this is e to the 2 times 0 minus 1 over 0. And so this gives me e to the 0 minus 1 over 0, which is equal to 1 minus 1 over 0, which is equal to 0 over 0. So we have that indeterminate form there. Okay, so what I'm going to do to indicate that I'm using L'Hopital's rule, and later on we will talk about when we start reviewing for the AP exam or possibly this week, how specifically they want you to tell them that you're using L'Hopital's rule. It's very, very specific. I'm not going to introduce it quite yet. I just want to get you familiar with using the technique and properly computing the limit first, because they are very picky on how they want you to express that. So for now, to express it to me that you understand what's happening, please do not tell me that the limit's equal to 0 over 0. Please put the 0 over 0 above the equal sign. And so under here, tell me that you're using L'Hopital's rule. Okay, you can also just write LH rule if you don't want to write out the whole thing yet. Okay, so now I'm going to say that this limit is equal to the limit as x approaches 0 of the derivative of the top divided by the derivative of the bottom. Okay, so now going on to the next line here, when I compute the derivative, I get that this is the limit as x approaches 0. Now the derivative of e to the 2x, that's e to the 2x times the derivative of 2x minus 0 all over 1. And so this gives me the limit as x approaches 0 of e to the 2x times 2 over 1. And so now let's try to plug back in 0 in for x, now that I've applied L'Hopital's rule. So I get that this is e to the 2 times 0 times 2 over 1. And so this gives me e to the 0 times 2 over 1, which is 1 times 2 over 1, which is 2. Okay, so this limit is 2. Alright, so now let's do another one here. So the only other note that I forgot to just mention, but I have down on the page here, is that you may have to apply L'Hopital's rule multiple times to compute the limit. So as you notice here in practice 1, we only had to apply L'Hopital's rule once, right? Because what I did is I plugged in, saw that I got that indeterminate form, 0 over 0, and then I took the derivative of the top and the derivative of the bottom, and then when I plugged back in, I got a number. Now, if I plugged back in and got 0 over 0 again, then I would have to, again, apply L'Hopital's rule by computing the derivative of the top divided by the derivative of the bottom again, and then continue onward. Okay, so let's do some side work here. Let's plug in 0 for x.